Okay. Now let us assume that all the variables are 0 at 0 nanoseconds. Okay. So all the variables, these variables A, B, C, D, E, all these are having the value 0 at 0 nanoseconds. Okay. Awesome. Okay, so let's see here. So here we have assumed that all these values like A, B, C, D, E. I'm just writing in short that we have assumed that all are having the value 0 at 0 nanosecond. Anyone wants to do that? Okay, let's say now the value of A is changed to 1 at 10 nanoseconds. So all these A, B, C, D, E, all these variables are having the value 0 at 0 nanoseconds. Then suppose A is changed to 1 at 10 nanoseconds. So now, as you can see that A is in the sensitivity list. So that's why now these statements will be executed since there is a change to A. Whatever in the sensitivity list, if there is a change to that, so now the process will be executed. So now you know that these statements will be executed sequentially. Okay, but the change in D does not happen here because here you can see that D equal to A or B. So value of A is changed. Now A is changed to 1. B value is 0, so 1 or 0. So that is equal to 1. But here we have written what? After 5 nanosecond. We have given a propagation delay. So that's why the change in D does not happen right at the execution. It takes what? 5 nanosecond. So means D will become 1 when after 15 nanoseconds. A is changed to 1 at 10 nanoseconds. So again after 5 nanoseconds means after 15 nanoseconds. So this D will become 1. But after that you can see that this statement is there, E equal to C or D. Okay. So now this value of D1 has not been propagated. So means value of D has not become 1 here. The value of D is still 0. So that's why E stays at 0. Since the change in D does not propagate to signal E because there is a propagation delay. So here value of E is still 0. Okay. So that's why you can see that this BSDL model is not equivalent to the 2 gates. So the 2 gates in the last class that we have discussed. So the same thing here we are using the process. In the last class we have discussed that example. Okay. This example we have discussed, the same example. But here we are using the process. So we should be careful while using the process for combinational logic. Okay, so that's what we are saying here, that here then if you are using this combinational if you are using the process for the combinational logic, so we should be careful. Like here what we need to do is, here we should also include D in the sensitivity list. If we'll include D in the sensitivity list, then what will happen? If any changes to D happens, so this will cause the process to execute once again. So that now whenever D value will become 1, so there is a change to D, so that's why these will be executed once again, and the value of E will be also changed to 1 at 20 nanoseconds. So here what changes we need to make is, we have to also include D in the sensitivity list. If you are not including, then as here D changed, but there was a propagation delay, value of E becomes 0, but value of E should be 1. So that's why when there is a change to D, so because E is dependent on that, so you should also include D in the sensitivity list. Then we'll get the correct result, which will be matching the circuitry with the cascaded gates. So I hope this is clear, or is there any doubt here? Sequential statements. Okay. So next we'll see modeling flip-flops using BSDL process. Okay. So flip-flop, as we have already studied in digital logic design. So here flip-flop, this can change the state either on rising or on falling edge of the clock input. So if there is a rising or falling edge of the clock input, let's say clock input becomes 0 to 1, or that becomes 1 to 0. Okay, so the flip-flop state can change. So this type of behavior can be modeled in the BSDL by a process. So you can use process to model this using BSDL. So let's say consider a simple D flip-flop. So you can see this is a D flip-flop. So with a Q output, as you know, Q is the output. So this changes on rising edge of the clock, CLK. So how we can model this using BSDL process? So what we'll write? So this is the keyword process. Then if what clock changes, so this is sensitive to the clock. If clock changes, then the statements, sequential statements will be executed. So this clock or CLK we need to put in the sensitivity list. So you're writing this CLK. Then you have to write the begin keyword. So here we are writing this condition. So if CLK event, okay, so means there is a change in clock. Either it may be rising or it may be falling. And next we have written what? The AND keyword, and CLK equal to 1. So there is a change and CLK equal to 1 means it changes from 0 to 1. That means that is the rising edge of the clock. So at that time, so you see how you write this if is, you have to write if and then keyword. Like in programming, C programming, we are writing only if. So here in BSDL, you have to write then along with if. Okay. So if this condition happens, that CLK event and CLK equal to 1, and you know this is the comment line, double dash is the comment line. So you have written rising edge of the clock, means this value is changed from 0 to 1. Then Q equal to D. As you know, this is the signal assignment operator. So here you can see that we are saying if the flip-flop has a delay of 5 nanoseconds between the rising edge of the clock. So here we have not written any delay. Okay. So if let's say the flip-flop has a delay of 5 nanoseconds between the rising edge of the clock and the change in the Q output. So now we will replace this statement with, that is Q equal to D, will replace that with Q equal to D after 5 ns or after 5 nanoseconds. Okay. So these statements between this begin and end in a process, so they operate as sequential statements. As I told that these are what sequential statements in a process, so they are executed sequentially. So in the preceding process we saw Q equal to D, Q equal to D, this is the sequential statement. So this executes following the rising edge of the clock. As you see that when what I have written that here if CLK event and CLK equal to 1, then is a change in the clock. Following the rising of the age of the clocks, so that change happened. So if you are saying the concurrent statement Q equal to D executes whenever D changes, okay. So if you have written Q equal to D, so now what? This concurrent statement Q equal to D will execute whenever D changes, okay. So if we'll synthesize the above process, the synthesizer, this will infer that Q must be a flip-flop, because what? Since the D changes, okay. So if we synthesize the above process, the synthesizer infers that Q must be a flip-flop. When the synthesize is done, so the synthesizer will infer that Q must be a flip-flop, since it only changes on the rising edge of the clock. So as you know, in case of flip-flop, so the value changed on the rising edge of the clock. So now the synthesizer will infer that Q must be a flip-flop whenever this statement is encountered. So it will now infer that Q must be a flip-flop. So if we'll use what? Only the concurrent statement Q equal to D. Okay. So here what we have written that if CLK event and CLK equal to 1, okay, then this Q becomes D, means there is a change in clock, that is the rising edge of the clock. But if only the concurrent statement Q equal to D, so then what the synthesizer will do? So it will simply connect D to Q with a where or buffer. So now it will not infer that this is a flip-flop. But in the example, what we have written that there is a clock event. So on the rising edge of the clock it changes. So now the synthesizer will infer that Q must be a flip-flop. So in the previous example, that you can see that only CLK was in the sensitivity list. Here what we have put that only CLK. So this CLK we have put inside the sensitivity list, but D we have not put inside the sensitivity list. Okay, because that changing D will not cause the flip-flop to change the state. So only if there is a change in the clock and rising edge of the clock, at that time so the value of Q will change and it will be equal to D. But that if the D changes, that is not going to change. So it depends on the clock. So that's why whatever means it depends. So you need to put those inside the sensitivity list. So it depends on the clock. So you need to put the clock or CLK inside the sensitivity list. Next, another example you can see here that this is a transparent latch, and here we have put both G and D inside the sensitivity list. You can see the process. Here we have put both G and D inside the sensitivity list. As here you can see what we have written that inside the begin and end, if G equal to 1, then Q equal to D. Then you have to write this end keyword and this if block, then end the process. So here both G and D, these are on the sensitivity list. Hence if G equal to 1, a change in D causes Q to change. Okay. So we have put both G and D inside the sensitivity list. So here you can see that if the value of G equal to 1, well, if the value of G equal to 0, it doesn't matter. Okay, so we have written the condition if G equal to 1. So if G equal to 1, then Q equal to D. So here, but now if there is a change in D, so now that value will be assigned to Q. So since if G equal to 1, a change in D causes Q to change. Okay. If G changes to 0, the process will execute, because as you know that G is in the sensitivity list. If G value becomes 0, the process will execute, but the Q will not change, because we have put the condition if G equal to 1. Okay. So if G equal to 1, then only this statement will be executed. Okay. Otherwise, the process will be executed, but we have not written any condition for G equal to 0. So nothing will happen. So if G equal to 1 and there is a change in D, so the Q will change. Both G and D we have put inside the sensitivity list. So if that what G changes to 1 and D changes, so then Q will change. Q will become equal to D. Okay, so this is for the transparent latch. This is the VHDL code. I know that if a flip-flop has an active low asynchronous clear input, that is, we are denoting it as a CLRN, active low asynchronous clear input. So which resets the flip-flop independently of the clock. So it does not depend on the clock. So it resets the flip-flop independently of the clock. So then we must modify this process which we have used earlier in the figure 216, this one. So this you can see that now this flip-flop is having what? This active low asynchronous clear input, or CLRN. So this will reset the flip-flop independently of the clock. Okay. So it executes when either CLK or CLRN changes. So earlier we have seen that whenever CLK changes, so at that time the process will execute. Here if there is a change in CLRN, so that will be also executed. So this is CLRN, that is active low asynchronous clear input. So here you can see that both this CLK and CLRN we have put inside the sensitivity list. So that's why we have added this CLRN to the sensitivity list. So now the VHDL code for the D flip-flop with asynchronous clear, this is given here. So here you can see that what I have written, that process, this is the sensitivity list CLK, CLRN. Then you have to write the process within this begin and end keyword. This is the skeleton, you can see that begin and process. Inside that you have to write what? Whatever the sequential statements. Means this is the body of the process. So now you can see if CLRN equal to 0. So this, if this value equal to 0, then Q equal to 0. So this is independent of the clock. If once it becomes 0 means Q equal to 0. So that we have written here. Else if CLK event and CLK equal to 1. So this is as the previous example we discussed. Means there is a rising edge of the clock, then Q equal to D. So now this is the end of this if block, and this is the end of this if block. You can see that there are two ifs. So this is the end of this inner if, you can see, and this is the end of this outer if. Then end process. Okay, so now here you saw that two types of sequential statements. One is signal assignment statement. So these are the signal assignment statements, as you know. Okay, signal assignment statements. Another is if statements. So here we saw two types of statements, two types of sequential statements. One is signal assignment statement, another is if statement. So what is the syntax for this basic if statement? As you have already studied in programming C, C++, Java, like we have already seen this if block. Here how we can represent that? That is again if condition then sequential statements 1. So here then will be there. If condition, then sequential statements 1, else sequential statements 2. Then you have to end this if. So end if semicolon. As you know, the condition, this is always what a Boolean express that is evaluated to either true or false. Okay. So like if this condition is true, then if this condition is true, sequential statements 1 is executed. If the condition is false, sequential statements 2 is executed. So this is one syntax that we saw. Now the general form of if statement. The general form of if statement is this, you can see, like if the condition is true, then sequential statements. So this else if, you can see that the else if ladder you have seen in C, like you write that in C you write else if. Okay. Right, in Python you know that you write elif. Similarly in VHDL we are writing this else if ELS IF. Okay. So you can see that the else if ladder what we have seen in C, similar to that. So this else if condition, then sequential statements. So these we have put inside the curly brace. So in VHDL, if you are putting something inside the curly brace, this means what? 0 or more times it can be repeated. So either you simply have a if statement or this else if ladder will be there. So this can appear 0 or more number of times. Okay, so this else if may appear 0 or more number of times. Then you can see within square bracket we have written else sequential statements. So this is again optional, means if you have else if ladder, then this else will come. Otherwise, this is the simple if and this is the end of if. If else if ladder is there, so this will appear. So this will appear at least one time. So if else if ladder is there, so it will appear one or more number of times. If that is not there, so this will not appear. Okay. If it appears at least one time, then so this will appear. Else sequential statements will appear. Means if all the above conditions are not satisfied, then this condition will be satisfied. The else part will be satisfied. So these sequential statements will be executed. Okay, next you can see the example below, that the below figure. This shows how a flow chart. Here you can see the flow chart. So this how you can represent this by using what, that is nested if, and another is else if. Like here you can see. So this is the flow chart. Like first we are checking this condition C1. Let's say if this condition C1 is true, then statements, sequential statements S1 and S2, these are executed. Let's say if the condition is false, we are checking another condition C2. If this is true, then sequential statements S3 and S4 are executed. So if this is false, then the condition 3 is checked. If this is true, sequential statements S5 and S6 are executed. If this is false, sequential statements S7 and S8 are executed. So this flow chart, this you can now represent using the nested ifs. So this is the nested if, or by using else ifs. This is the else if. So you can see that this is by using nested if. So if C1, then what, you have to write the then keyword, then is S1 semicolon, this is a statement, so that will end with semicolon. Then S2 is another statement that will end with semicolon. So then else if, this is the nested if. So you are writing what, else if. So else if, we are checking the condition C2. Else if C2, then what? This S3, S4, this will be executed. Else if C3, then this S5, S6 will be executed. So next here you can write corresponding to this if this is not satisfied, okay, then else this S7, S8, this will be executed. Now you can see the end of if. So first end of this inner if. So this if is the end of this if. Next, after that you can see this if, this is the end of this if. Next you can see this if, and this is the end of this if. Okay. Like first if, this is the end of this means innermost if. Then this if and the end of this if, and this if and this is the end of this if. Okay. So this is by using the nested if. If you are using else if, how you can represent this? Like if C1, then S1, S2. So else if you are writing what? ELSIF, else if. So else if C2, then this S3, S4. Else if C3, then this S5, S6. Otherwise, if all the above conditions are not satisfied, then this will be executed. So else S7, S8. And this end if will use only once. So there is only one if here. So this is the end of that. Okay. So all these are else if, else. Here what? Here if appears, so you have to end this if. Here if appears, you have to end this if. Here if appears, you have to end this if. Here there is only one if appear. So this is the end of this if. So this flowchart that you can see by how we can represent that by using nested if and else if. So next we'll write a BSDL module for a JK flip-flop. Okay. So you can see this JK flip-flop. So this flip-flop has active low asynchronous preset, that is SN, and clear or reset. So that is what? RN. Okay. So SN and RN input that you can see. So active low asynchronous preset, that is what? SN. So this one. Okay. And another is the clear or RN input. So these are the inputs. You can see that SN, RN, SN and RN. So your state changes related to this. Okay. So first, for simplicity, we are assuming SN equal to RN equal to 0. This never occurs. Now you see the BSDL code for the JK flip-flop. This is given below. Here the JK flip-flop model you can see. So you can see that how we declare an entity, that you know, entity keyword, then the entity name. So here for JK flip-flop we are writing JKFF. So you have given the entity name as JKFF. Then is keyword. Then you have to declare the port. So here what we have used, you see what are the inputs and outputs that we have taken. So inputs, you can see that SN, RN, J, K, CLK, or these are inputs. Okay. SN, RN, as you know, J, K, CLK, or all these are the inputs, and Q and QN, these are the outputs. So all these are what? Input. So mode is in, type is bit, and Q, QN. So these are what? Output signals. So mode is out, type is bit. And this is the end of this entity. Entity name is JKFF. Then you have to describe the architecture. So you have to write the architecture keyword, then architecture name, let's say JKFF1 we have given. So then you have to write the of keyword, then the entity name. So entity name, whatever you have given, so that will write JKFF, then is keyword. Then here you have to declare, here you can see that we are seeing a signal qint. So qint, this is the internal signal which can be used as input or output. So here as you saw, the port declaration first in the entity, this define the input and output signals. These are the input and output signals. Okay. So within the architecture, we define a signal qint. So this represents the state of the flip-flop internal to the model. Qint, so int stands for the internal. So this represents the state of the flip-flop which is internal to the model. And the two concurrent statements after begin. This transmits the internal signal to the Q and Qn outputs of the flip-flop. You can see that here. So that this signal Qn, which is the internal signal, so as you can see that here we have not specified the mode as in or out. This is the internal signal and the type is bit. Next, after that, okay, you have to write within this begin and end. Okay, so within this begin and end of the architecture, you have to write the statements. So here you can see that now here you have written what q equal to qint and qn equal to not qint. Okay, so this is the signal assignment operator. This is the output q and this is the output qn. Okay, so these are the outputs. So q equal to what? Qint, whatever q internal, and qn, as you know, qn is the complement of q. So that's why qn equal to what? Not qint. Okay, so this is the output q and qn to port. So these are all command lines. So these are the combinational output which is okay. So we have not defined the process. After that, we will define the process. So this is outside the process. These statements are outside the process. After that, we are defining the process. As you know how to write the process, so that is you have to use the keyword process. Then you have to write the sensitivity list. So here it depends on what, that is SN, RN, and CLK. So if there is any change to SN, RN, and CLK, so these sequential statements will be executed. So SN, RN, and CLK. Okay. These we have put inside the sensitivity list. Then you have to write what? The process sequential statements. You have to write what? Within this begin and end process. Now you see, if Rn equal to 0, as you know, Rn and Sn, these are independent of the clock. If Rn equal to 0, then Qint equal to 0. And we have taken a propagation delay of 8 nanoseconds, after 8 nanoseconds. Else if Sn equal to 0, then Qint equal to 1, right? If Sn becomes 0, then Qint equal to 1 after 8 nanoseconds. As you know, Rn equal to 0 means what? This will reset the flip-flop, or this will clear the flip-flop. And Sn equal to 0 means what? This will set the flip-flop. Okay. So this will set the flip-flop. Else if, okay, so these Rn and Sn that you can see, these are independent of the clock event. Okay. So after that we are checking the clock event. Else if CLK event and CLK equal to 0, we have told what? Falling edge of the clock. Falling edge of the clock event means we are saying that clock event is there. Earlier we have seen that in case of D flip-flop, rising edge of the clock, CLK equal to 1. This is the falling edge of the clock. So CLK event means there is a change in clock, and CLK equal to 0 means it becomes from 1 to 0. That is the falling edge of the clock. So here, this is the equation that Q plus equal to how you find out the Q plus. You see, in case of JK flip-flop, okay, how you find out the Q plus? Just we have modeled it. This is the equation, characteristic equation of JK flip-flop. That Q plus equal to what? Q plus is the next state of Q. So that is equal to J Q prime plus K prime Q. So that means here you can write what? J and not Q int. Okay. So this is and, as you know. So let's say you've written J and not Q int. Then this plus means or then not K. K prime means not K. Okay. And you know this and Q. So and here Q int. Okay. So we are finding out the value of Q int. As you know, this Q int will be assigned to Q. Here we have written this Q equal to Q int. So this is the end of this if block, and this is the end of the process, and this is the end of the architecture. They have started the architecture here. So this is the end of the architecture and JKFF1. Okay. So this is we have modeled this JK flip-flop. Okay, next as per your lesson plan, next will be 2.10. Okay, so next we'll see this VSDL data types and operators. So as you know that in all the programming languages, there will be some data types and operators, like in C, C++, Java, Python, you have studied whatever the data types and operators are present in those programming languages. So here similarly, what are the data types and operators in VSDL we'll see. So this has several predefined data types. Signals can have these predefined data types, or they can have user-defined data types. Okay, so we can have for predefined data types, several predefined data types are there, as well as user-defined data types are there. So some of the predefined data types, these you can see, these are the predefined data types like bit, boolean, integer, real, character, time. All these are the predefined data types. As you know, bit, this can have the value what? Either 0 or 1. So here you have tried within single quote, that is 0, or it may be 1. And you know boolean, that is having the value false or true. So false or boolean, as you know, this can contain the value false or true. And integer, this is having the range from minus 2 to the power 31 minus 1 to plus 2 to the power 31 minus 1. And some implementation can support a wider range. And real, this is the floating point numbers, so that is in the range minus 1.0 E38 to plus 1.0 E38. Character, this can be any legal VSDL character. This can be upper and lowercase letters, digits, special characters. Okay. So these must be enclosed in single quote. So character means you have to enclose it within the single quote. So within single quote, you can see, for example, within single quote D, within single quote 7. So this 7, you can say this is integer, but if you're writing within single quote, now this is a character. Or this plus, you have written within single quote. So plus is a operator, but now if you're writing within single quote, so that is treated as a character. Now the time, this is an integer with units like fs, ps, ns, okay, like nanoseconds, milliseconds. So SEC second, MIN minute, or HR hour. Okay, so the integer range for VSDL, this is symmetrical. Okay. Even though the range for 32-bit 2s complement integer is from minus 2 to the power 31 to plus 2 to the power 31 minus 1. So these are all predefined data types. This bit, boolean, integer, real, character, time. And we can also create our own data types. Those are the user defined data types. So the common user defined data type is the enumeration. Okay. So we can use the enumeration type. This is an user defined data type. So for example, here you can see how we can create one user defined data type. So what you have to write? You have to write the type keyword. So type is a keyword, so that you have to write type. Then you have to write the user defined data type name. So state underscore type. Here we have given the user defined data type name. Whatever name you want, you can give. So here you have written state underscore type. Then is keyword. Then writing this means this can have this state underscore type, this data type, this can have one of these values like S0, S1, S2, S3, S4, S5. So this is a state type. So this is having the value, this can have the values S0, S1, S2, S3, S4 and S5. Then we are defining a signal. Now already you can see that signal, here we have mentioned the type. Then next signal. Okay, so you have to use a signal keyword. Then signal name we have given as state, and next we are mentioning the type. So already you have created one user defined data type, that is what state underscore type. So now that type I am mentioning, and here I have written what colon equal to S1. This means what? Now this is initialized to S1. This state is initialized to S1. So if you will not initialize this, if no initialization is given, the default initialization is what? The leftmost element in the enumeration list. So this will be assigned. Means if you will not write this, if you write only a state type semicolon, then this state type will become what? S0. So this VHDL, this is a strongly typed language. Means what? As you know, strongly typed language. So it strictly checks the data type. So signals and variables of different types generally cannot be mixed in the same assignment statement. And no automatic type conversion is performed. Like in C or C++, we have seen that automatic type conversion can be performed. Here, automatic type conversion cannot be performed. So like suppose you are writing a statement A equal to B or C. So this will be valid if A, B, C all have the same type or closely related type. Okay. Otherwise, this will not compile. Okay. This is a strongly typed language. Then what are the various VHDL operators? You see. So predefined VHDL operators, they can be grouped into 7 classes. There are 7 classes for the VHDL operators. So first class, you can see that is the binary logical operators. So all of you know this logical operators, that is what AND, OR, NAND, NOR, XOR and XNOR. So all these are binary logical operators. So this is the class 1, that is binary logical operators. Then the relational operators. So class 2 is the relational operator, that is equal to, this is not equal to, you give a symbol like this. When say writing slash equal to, that stands for not equal to in VHDL. So this stands for not equal to. Then less than equal to, greater than equal to. All these are relational operators. Then shift operators. So these are all shift operators. SLL, that stands for shift left logical. SRL, this stands for shift right logical. And SLA, this stands for shift left arithmetic. SRA, this stands for shift right arithmetic. ROL, this stands for rotate left. And this ROR, this stands for rotate right. So all these are shift operators. Next is the next class 4 is the adding operators. That is what? Plus, minus. As you know, addition, subtraction, and this stands for concatenation. As in this ampersand. This ampersand stands for concatenation. Then unary sign operators. Unary sign, as you know, that plus or minus, positive or negative numbers you can make. Unary sign operators. Then multiplying operators. So as you know, star, this stands for multiplication, or then this class is for division. So these are coming under this class, like these are similar. So star multiplication or slash division, mod, that is modulus, rem, remainder. So all these are coming under multiplying operators, that is class 6 multiplying operators. Then next class 7 is the miscellaneous operators, that is not, as you know, not operator. Then abs, abs, that stands for absolute value. You can find out that, you know, if you are finding absolute value of minus 7, that is plus 7. So that is the positive value that we get. So abs, abs. Then this double star, as you know, this is the exponentiation operator. So that is the power. So if we are not using the parenthesis, then these operators in class 7 have the highest precedence. We saw the class 1 to class 7. So class 7 is having the highest precedence and class 1 is having the least precedence. Was trying to join. I think all of you have already added. You can directly join. Actually, I have not seen that someone is trying to join. Okay. Okay. So, as we discussed, these are all operators from class 1 to class 7. Like class 7 is having the highest precedence and class 1 is having the least precedence. So, whenever there will be an expression, so we'll see the precedence of these operators and accordingly we'll evaluate that. So class 7 has the highest precedence. So these are applied first, then followed by class 6, 5, and like this. Class 1 is having the lowest precedence. So, but if you are using parenthesis, as all of you know, so whatever inside the parenthesis, those will be evaluated first. So if you want to change anything here, so like if you want something to be evaluated first, but that is not having more precedence, so those you can put inside the parenthesis. So like consider this example. So here A, B, C, D all are the bit vectors. Bit vectors are array that we have already studied. So here this you can see that what we are doing, we'll evaluate this and we'll compare whether this is equal to this value 110010 or not. So this is a relational expression. Okay. So relational expression performing an equality test, whether the value of this left hand side is equal to this or not. So equality test we are doing. So now evaluate this expression, the operators, you can see that like the operators are applied in which order. As for order, you can see class 7 is having the highest precedence. So here you can see there is an operator not. So this operation will be done first. Then there is an operator ampersand. Okay, after not this, that is the concatenation operator. So that not, then concatenation. Then comes what? There is ROR. After that ROR, rotate right. Okay. Then after that, after ROR, OR is there here. You can see that OR. After ROR, this OR. Okay. Then AND, then equal. You can see that OR, AND, and lastly this equal. Okay, so you can see that this or and like they are in the class 1. Okay, they are in the class 1. So how, if they are in the same class, how they will be evaluated? So they will be evaluated from left to right. Like here or is in the left and is in the right. So first or will be performed, then and will be performed. So now let's take the value of, you have to assume what is the value of A, B, C, D, and we'll do the computation and we'll check the result if we are getting this value or not. So like here you can see that value of A, it has taken that straight. The value of A, it has taken as 110. Then B equal to 111. C equal to 011000. So 11000. C equal to 111. 011. You can see that we saw that not is having the highest precedence, which will be performed first. So first not B will be performed. So here you can see that the value of B equal to what? 111. So not B, as you know. So it will invert the bits. So that means this 111 will become what? 000. Right? So not B will be equal to 000. Okay. Then you have to perform this concatenation. So A concatenation, not B. So what is the value of A? You can see that 110. So A concatenation, not B. The value of A equal to 110. Then not B is 000. Okay. Then next you can see that you have seen that ROR will be performed. Okay. So ROR, you can see this ROR. So C ROR 2. Okay. C ROR 2. I can see what is the value of C. C ROR 2. So this is the value of C. C ROR 2. ROR stands for rotate right. So rotate right, 2 stands for 2 place. So rotate right 2 place. So what will happen? So this, you can see this is present on the right. So rotate right 2 place. So okay, so see. What was this value of C is 001100. Okay, so this rotate right means whatever on the whatever is present on the right. Okay, so this will be rotated. So what we have written 2, ROR 2. So 2, you can see that this is the rightmost 2 places. So this will come to here. Okay. So first this 00 will come. Next this 0110. Okay, so C ROR 2. Next after or, that is or. Okay, as for class of operators or. So you can see the or here or. Okay, so we have already performed this A and not B. Okay, so A and not B and C ROR 2. Okay, so now we have found out, we'll find out OR of these two. Okay, so OR of these two, so A and not B. Or C ROR 2. Now you see, so OR operation, as you know, this will be done bit by bit. So if both of them are 0, the result will be 0, otherwise it is 1. So now you see this 1 or 0, so this will become 1. Next this 1 or 0, so this will become 1. Next is 0 or 0, so this will become 0. Next 0 or 1, so this will become 1. Next 0 or 1, so this will become 1. Next 0 or 0, so this will become 0. Okay, so 1 1 0, 1 1 0. Okay, so this or this is gone. Next is what? And. Okay, so these we have found out. Next this and D. Okay, now you see this we have found out. That is what? A and not B, or C ROR 2. This is ROR 2. C ROR 2. Then what? And D. Okay. This will now find out. So D, you can see that this is the D, that is 1 1 1 0 1 1. Okay, so just write here the value of D, 1 1 1 0 1 1. So now this and this, so this will be equal to what? As you know, in case of AND, when both of them are 1, the result will be 1, otherwise it is 0. So now first 1 1, you can just see that I am not writing it 1 1. Okay, otherwise it will appear again 1 1. So just see 1 1 here, so we'll get what? 1. Next 1 1, second 1 1, we'll get 1. Then this is what? 0 1, so this will become 0. Then next 1 0, so this will become 0. Next 1 1, this will become 1. Then 0 1, so this will become 0. Okay, so 1 1 0 0 1 0. Okay, so 1 1 0 0 1 0. So this is what we obtained, 1 1 0 0 1 0. This means what? Now this is equal to this, means this is true. Okay, so this will find out as true. Okay, so this is one example we saw. So the binary logical operator class 1 as well as NOT, this can be applied to bits. Okay, binary logical operators class 1 we see, AND, OR, NAND, NOR, XOR and XNOR. Okay, so all these can be applied to bits as well as NOT can be applied to bits. Bits as well as booleans, bit vectors and boolean vectors. And the class 1 operators, requires 2 operands of same type, and the result will be also of same type. Okay, so here, as you know, all these AND, OR, NAND, NOR, XOR and XNOR, it requires all the operands are of the same type, and the result will also be of the same type. Okay, as you know, the result of relational operator, as you know, that is always Boolean, means relational operator, as you know, that the result is always Boolean, that is what? Either true or false. And in case of these relational operators, this equal or not equal, so this can be applied to almost any of the data types. And but the other relational operators like less than equal, greater than equal, so these can be applied to any numeric or enumerated types. Okay, and it can be also applied to array types. Like for example, if you're writing a equal to 5, b equal to 4, c equal to 3, you can see that all these are integers. Okay, and you can evaluate this expression like a is less than equal to b, 5 is less than equal to 4. Like this is false, so false and something whatever it is, true or false. So it will evaluate the result to be false. And the shift operators, that whatever all these shift operators, that is class 3. Okay, so class 3 shift operators can be applied to any bit vector or Boolean vector. Like here we'll see a SLL2. So what is the value of a? It is taken from here. Or okay, sorry, a value is this, that is 1001 0101. Okay, so shift left logical. So SLL stands for shift left logical. So SLL2 means shift left logical by 2 places. Okay, so what will happen? So here you see that what is the value of a? So a equal to 1001. Then 0101. Okay. So if I write a SLL2. So SLL stands for shift left logical. So this 2 means it will be shifted to left by 2 positions. Means what? Now all these bits will be shifted by 2 positions. Like this 1 will come to here, this 0 will come to here. Okay. Like that, this 1 will come to here, this 0 will come to here. I can see that now in this process what will happen is this 1 0 will go away because these are the 2 leftmost bits. So other whatever is there is just right. After this 1 0, what are there? 0 1 0 1 0 1. Okay. Then now the rightmost 2 bits you fill with 0. So that is 0 1 0 1 0 1 0 0. Okay, so that is shift left logical. Similarly, SRL, a SRL3. So SRL stands for what? Shift right logical, then filled with 0. So shift right logical, a SRL3. Okay. So now again see that it will be shifted towards right by 3 positions. So these 3 bits, they will go away, right? So now you just write this, what is that? 1 0 0 1. You can see that up to these 3, and this 1 0 1 will go away. So now rest is what? 1 0 0 1 0 1 0 0 1 0. So this has been shifted to right. So leftmost 3 positions will be vacant. So you just fill with 0. So 0 0 0 1 0 0 1 0. Okay. So this is what shift right logical SRL 3 means by 3 positions. Okay. So whatever will be vacant, those will be filled with 0. Then next you can see SLA, shift left arithmetic, SLA 3. Okay. So in this case, what happens? So means this will be shifted towards left now by 3 positions. So now rightmost 3 positions will be vacant. So those will be filled with what? Filled with right bit. Earlier here we are filling with zeros. Here we will fill it with right bit. So just see SLA 3. So shift left arithmetic by 3 positions. So these will be shifted towards left by 3 positions. So now what will happen? So these 3 will go away. 1 0 0. Okay. These will be shifted towards left. 1 0 0 will go away. Rest whatever is remaining. 1 0 1 0 1. Okay. So 1 0 1 0 1. Now rightmost 3 positions are vacant. Fill it with rightmost bit, that is 1. Rightmost bit is here what? 1. So now if it would have been 0, you would have filled it with 3 zeros. Now it is 1, so this is 3 1. So 1 0 1 0, then 4 ones. Okay, 1 0 1 0, 4 ones. Similarly, SRA 2, so shift right arithmetic. Okay, it will be shifted towards right, and now it will be filled with leftmost bit. Again, like let's say ASRA 2. So shift right arithmetic by 2 positions. So these 2 will go away. This 0 1. So rest is what? 1 0 0 1 0 1, right? So leftmost 2 positions are vacant. Fill it with leftmost bit. So that is what? 1. So here you fill it. So 1 1 1 0 0 1 0 1. Okay, so this is what? Then ROL, that stands for rotate left. Okay, so rotate left by 3 positions. It is written. So ROL 3. Okay, so rotate left. So from the left side, so this will be rotated like this 1 0 0. So this will be rotated and this will come here. Okay, so 1 0 1 0 1. This is what is remaining. 1 0 1 0 1. So this 1 0 0 will come next. So 1 0 1 0 1, then 1 0 0. Okay. So rotate left means what? We are rotating from left. So you do not think that we are rotating right. Okay. Rotate left means rotating from left. So you can see that rotating from left. Now here by 3 positions. These 3 will come here. Okay. Similarly, ROR 5. So rotate right by 5 positions. Okay, now you see from the right 5. 1 2 3 4 5. So this 1 0 1 0 1. Okay, so 1 0 1 0 1. Okay. So this will come to the left 1 0 1 0 1. Next is 1 0 0. Okay. Okay, so ROR 5 means rotate right means now we'll see from the right. Okay, from the right, we'll rotate what now? 5 positions. So rightmost 5 bits, that is 10101. So this will come to what? Left 10101. Okay. So now automatically this will be shifted towards right. This 100. So this is shifted towards right. So this is ARR5. So now these plus and minus operators, as you know, these can be applied to the integer or real numeric operands, addition or subtraction operators. So these can be applied to integer or real numeric operands. These are not defined for bits or bit vectors. Okay, as you know, this addition or subtraction, they are not defined for bit or bit vectors. So for that purpose, we are using the full adder. Okay. And this ampersand or concatenation operator, this can be used to concatenate two vectors. Like if you're writing 010 ampersand 1, so this becomes what 010, then 1 is concatenated, so this becomes 0101. Or ABCDEF, so they are concatenated, this becomes ABCDEF. And this star and slash operators, you know, this performs the multiplication and division on what? That is integer and floating point operands. Okay, this multiplication and division performed on integer and floating point operands. This REM and MOD, that is a remainder on modulo division, MOD stands for modulo division operators. So they calculate what? That is, this REM calculates the remainder and this MOD calculates the modulus. This does the modulo division operation. So these are acting only on integer operands. Okay, REM and mod operators can be applied only to the integer operands. And this star, as you know, this is the exponentiation operator. That is the power. So this operator raises an integer or floating point number to an integer power. And the asks find the absolute value of a numeric operand. As you know, like -7, its absolute value is +7, or if you are writing +5, its absolute value is +5. So that is the absolute value. Okay, so as for the lesson plan, we have covered up to this. Now you tell if there is any doubt. And 6, as for the lesson plan, 2.10 is there. 2.789 is not there. Okay. All of you just mark your attendance. Just wait. Okay, all of you just tell your registration numbers. PT.
Yes, sir. It's 204-101-8112.
Okay. Next, Subham Patnaik.
Hello. Yes, sir. It's 20410. It's 20410-16177.
Okay.
Okay.
Next. Okay, Arpan.
Sir, 204 100 203.
204 100
203.
2025.
35, sir.
Okay. Next, Siddhant Surup Malik. Hello. Okay. Next, Esika.
Yes, sir. 2041
Yes.
005 002.
Okay. Next, Vaibhav Singh.
Sir, 20410 22001.
Okay. Next, Susri Sriya.
Yes, sir. 204 101 3103.
204 101 3103.
Yes, sir.
Okay. Next, Sweta Padma.
Yes, sir. 204 100 4040.
Okay. Next, Supriti.
Sir, 204 101 9297.
Who else left? Okay, who else left? Yes. Okay. Okay, who else left? I think there are total 11 students. Sorry, 10. 11. 1. 10. One is left. Or what? Okay, then everyone has marked your attendance. Okay. Okay, thank you, all of you.
Sir, your voice is being echoed.
Voice is?
It is echoing.
हाँ मेरा आज नेटवर्क प्रॉब्लम है बिकॉज क्लाउडीनेस है आई डोंट नो एंड टुडे आल्सो आई एम नॉट इन कॉलेज दैट्स व्हाई मेरा वॉइस प्रॉब्लम हो सकता है आज अभी ठीक है इज इट ओके नाउ
No, sir.
स्टिल इट इज ओके
Yes, sir.
okay let me try what I can do I have joined with an headset also it's echoing now
Sir, we can switch to RL's Google Meet.
no it's college is or arranged this one so I don't know so we cannot go to Google Meet just 1 minute I am leaving and joining again is it okay now yeah it's still echoing
Little bit echoing.
So I cannot do anything because I have joined with mobile network and today is Sunday, so मैं कॉलेज भी नहीं जा गया हूँ तो ठीक है. सो मैं स्टार्ट करता हूँ. Even I have used a noise cancellation earphone. Still अगर हो रहा है तो So last class we have solved about this one, monthly average daily global radiation. So now today what we will do, I have told you to write down monthly average daily diffuse radiation. We have two formula, Gopinathan and Solar formula and Garg and Garg formula, 4.21 and 4.22. So please note down these equations 4.21 and 4.22 and we'll proceed. You can take the screenshot those who are not present yesterday's class. We have done this one in yesterday's class, monthly average daily diffuse radiations. I have already told you diffuse radiations means the radiations that is absorbed by the ozone layer, absorbed by other dust particle. Okay, so similar from previous example only, from the data given in example 4.4. Previous class we have solved your Hg bar, H0 bar we have calculated, and for the same location we have to estimate monthly average of daily diffuse radiations. Please see it, question is estimates the monthly average of daily diffuse radiations on a horizontal surface as per Gopinathan solar formula as well as Garg and Garg estimates. So those who are present yesterday, you have already calculated H0 bar, you have calculated H0 bar, you have calculated Hg bar. So please take that one and for first calculate with Gopinathan and solar formula. You have already calculated TD max also, TD max bar you have calculated yesterday's class. TD bar is 9.5 hour, it's given in the previous questions. Okay, so please use your data and calculate HD bar according to Gopinathan and solar formula. Ansa, have you got what I am telling? What's your name? Something, just 1 minute. Asna Isika. Have you got
Yes, sir.
what I am? Okay.
Yes, sir.
So Hg value is with you, Hg bar value, H0 bar value is with you. So please use that values and calculate KT bar is Hg bar by H0 bar. You have Hg bar value, H0 bar value, TD max value, TD value. Then calculate HD bar value. Okay, from Gopinathan and solar formula. First, you have to calculate from with the help of Gopinathan Solar. Then we'll go for Garg and Garg formula. Just 1 minute. Please directly do not tell me the values in written in the book because I have calculated this one. So मेरे को पता है किस range में आएगा. Have you calculated KT bar value, Asna?
Yes, sir. Doing, sir. Actually, I
Have
had
you
lost.
calculated KT bar value?
No, sir. Just a second.
हाँ हाँ. कोई फाउंड किया KT bar value, HG bar by HG bar value? Please calculate with the previous class value we have got, not the values mentioned in the book. Anybody here in Bangalore, staying in Bangalore? Swatik Das, where are you staying? Bangalore. Anybody here in Bangalore? Please reply. I'm पढ़ाई के बात नहीं कर रहा हूँ.
Yes, sir. Yes, sir.
Where are you staying? Bangalore.
In Bangalore?
Where are you staying? Bangalore only.
Yes,
Which city
in,
you are in?
in Bangalore only.
How is the climate there?
Climate is nice. Humidity is
Okay.
not there.
Humidity is means actually what is the maximum temperature in daytime?
Here, first time it has touched 36 in the last 3 years. But
Okay, okay,
on an
okay.
average, it is 32 to 3. You can say.
In Bangalore, 32 means it's okay. Okay. थैंक यू फॉर शेयरिंग प्लीज डू द क्वेश्चंस केटी बार वैल्यू आप कोई दोस्त से कल एब्सेंट थे किसी से पूछ लो एच जी बार एंड एच जीरो बार का वैल्यू कितना आया था देन प्लीज प्रोसीड
Oh, I will ask Amit. He was present. Amit Mahapatra.
ओके थैंक यू Setopatma, are you there? Are you following?
Yes, sir.
Have you got the value of KT bar value?
Yes, sir. Calculating.
ओके प्लीज डू एक बार हो गए तो मुझे बता दो एच डी बार का वैल्यू गोपीनाथन फॉर्मूला के हिसाब से
Sir, KT bar value 0.62.
Okay, 0.62. Then please calculate HG bar values and H0 bar values with you. Previous class you have calculated. So please use the formula 4.21. All the data is with you. Please calculate HD bar values. And that is your monthly average daily diffuse radiation.
Sir, HD value is 6,600.
Yes, 6,600 kilojoule per meter square. Please write kilojoule per meter square. Then we have calculated HD bar value from this one, and so write down again Garg and Garg. ठीक है? Garg and Garg formula से HD bar value calculate करो. बाकी सब कुछ दिया हुआ है. HD bar value Garg and Garg formula से calculate करो जो 4.22 में mentioned है. Have you calculated HD bar value from Garg and Garg formula?
Yes, sir, 7,648.
7,000. Can you please check once? थोड़ा मतलब थोड़ा ज्यादा है मुझे लग रहा है. 7,600 नहीं आएगा. 7,000 ही आना चाहिए. एक बार चेक कर दो. Have you calculated again? Is it coming 7,600?
No, sir, 6,600 something. I had done some mistake.
Okay.
I'm calculating it Gopinath formula again.
Okay. Setopadma, have you done?
Yes, sir. Getting 6,829.
Okay. So just let's wait for some time. Then after उसका हो जाने के बाद then we'll go for monthly average hourly global radiation.
Yes, sir, done.
Okay. So then हम चलते हैं monthly average hourly global radiation. See again, this is some of the empirical formula I have told you. So empirical formula में directly मैं just empirical expression बता रहा हूँ, अब उसका notation भी बता दूंगा. So ये please this is your global previously जो गया वो पहला वाला था beam radiation. देन ये जो गोपीनाथन सोलर और गर्ग एंड गर्ग ये था डिफ्यूज रेडिएशन. एंड अभी जो टोटल है मंथली एवरेज आवरली ग्लोबल रेडिएशन, डिफ्यूज रेडिएशन प्लस बीम रेडिएशन इज योर ग्लोबल रेडिएशन या टोटल रेडिएशन. Okay, so generally we are using this formula Ig bar divided by Hg bar equal to I0 bar by H0 bar into A plus B cos omega. This omega is your sunshine hour. This omega is your solar hour. How to calculate this omega? This omega is, we'll see in the problem how to calculate this omega. So this is your and you're divided by Fc. So Fc is a solar constant again, and whose value is A plus 0.5b omega s minus sin omega s cos omega s divided by sin omega s minus omega s cos omega s. These are some empirical formula. No need to worry. This type of formula will be given to you. और इसमें से बहुत सारे फॉर्मूला दिया जाएगा. जो नहीं दिया जाएगा मैं आपको एक फॉर्मूला शीट करके दे दूंगा. कौन सा फॉर्मूला नहीं दिया गया आप उसी को याद करके जाना एग्जाम में. एंड व्हाट इज A and B? The A and B is again a constant. So whose A value is 0.409 plus 0.5016 sin omega s minus 60. B value is this much 0.66 minus 0.4767 sin omega s minus 60. So what is your Ig? Ig is your monthly average of the hourly global radiation. Okay, monthly average of the hourly global radiations. ओके, मान लो कि तुम मार्च 15 का 11 से 12 बजे सॉरी मार्च मंथ का 11 से 12 बजे के बीच में कितना ग्लोबल रेडिएशन हो रहा है देखना चाहते हो पूरा होल ऑफ द मार्च मंथ, तो आपका ये है आपका Ig बार. एंड Hg बार तो प्रीवियसली देखे वो मंथली एवरेज ऑफ द डेली ग्लोबल रेडिएशन था वो. देन I0 बार इज द मंथली एवरेज ऑफ द आवरली एक्स्ट्रा टेरेस्ट्रियल रेडिएशन. जब I0 बार H0 बार हो गया, दैट वन इज योर एक्स्ट्रा टेरेस्ट्रियल रेडिएशन ऑन ए हॉरिजॉन्टल सरफेस. So do one thing, please copy these equations from 4.23 to Ig bar, I0 bar. Please copy this equation. I am giving you just 3 to 4 minutes. Please copy this equation, then we'll solve one problem.
Yes, sir. Noted the formulas.
Okay. Just 1 minute. Okay. So just 1 minute. So we'll repeat the same 4.4 questions for the same Coimbatore locations using this one. So you can refer that question again from 4.4. So here in 4.4 it is mentioned your phi is your latitude angle is 11.0183. You can write down. For example 4.6 अब इसका हमें क्या फाइंड करना है? हमें फाइंड करना है मंथली एवरेज आवरली ग्लोबल रेडिएशन वी वांट टू फाइंड. ओके, सो सिमिलर 4.4 का क्वेश्चन में जा रहा हूँ. मैंने आपको बताया 4.4 का क्वेश्चन में जा रहा हूँ मैंने. जस्ट 1 मिनट. सो इन 4.4 क्वेश्चन सी फॉर कोयम्बटूर लोकेशन व्हाट इज योर फाई. मैं बोला था हमेशा नॉर्दर्न लैटिट्यूड को ही फाई लेना. फाई इज योर 11.0183 डिग्री. Elevation is 411 meter above sea level. So please convert it into kilometer. We have done 0.411 kilometer. So your phi is 11.0183 and your elevation is 0.411 kilometer. And your month of the March में डे जब नहीं दिया था तो मैंने बोला था आपको n को मिड में ले जाना. n equal to 75 we have taken. We got your delta is minus 2.4177. प्लीज यूज जो कल जो क्वेश्चंस करवाया था उसका डेटा यूज करना. एंड ओमेगा इज यू गॉट परहैप्स अराउंड 89.6 ऐसा कुछ आया था व्हिच इज 1.56 रेडियन. एंड टीडी मैक्स बार वैल्यूज वी गॉट अराउंड 11 पॉइंट समथिंग आवर. प्लीज यूज दैट डेटाज. उसी डेटा को हमें यूज करना है. देन हमें फाइंड H0 बार एंड Hg बार वैल्यू जो थी वो ठीक है. हमें देखो ये क्वेश्चन में हमें IG बार फाइंड करना है मंथली एवरेज ऑफ द आवरली ग्लोबल रेडिएशन. ओके, टाइम क्या दिया है? टाइम दिया है ओमेगा इक्वल टू 11 आवर, एक ही घंटा के बीच में 11 आवर माइनस 12 आवर. सो व्हाट इज ओमेगा देन? ओमेगा इज ओमेगा 1 प्लस ओमेगा 2 डिवाइडेड बाई 2. दोनों का बीच का एवरेज है. तो जब 11 बजे व्हाट इज योर ओमेगा? मैंने एक फॉर्मूला बताया था आपको याद होगा. 12 o'clock minus solar time into 15 degree is your omega. 12 minus 11 is 1. 1 into 15 is 15. And for 12 hour, 12 minus 12 is 0. 0 into 15 is 0. So 15 plus 0 by 2, omega will get 7.5 degree. Okay, then after getting omega equal to 7.5 degree, you have to see in this equation you need your I0 bar because Hg bar value with you. Fc with the formulas you can get Fc with the formulas you can get A and B and omega, but you need I0 bar values. So you have to calculate I0 bar values जिसका फॉर्मूला मैं अभी दिखा रहा हूँ. मतलब लास्ट क्लास भी हम पढ़े थे I0 बार का फॉर्मूलाज, बट अभी बता रहा हूँ I0 बार का फॉर्मूलाज. यू कैन टेक स्क्रीनशॉट और जिसको आपको लिखना है तो आप लिख सकते हो. यू शुड फॉलो 4.16 का प्रॉब्लम. ओके, 4.16 का क्वेश्चन आप फॉलो कर सकते हो. दैट इज योर I0 बार. ओके, दैट इज योर I0 बार 4.16 का. मैंने एक बार दिखा रहा हूँ. जस्ट 1 मिनट. I0 बार cos omega. just 1 minute. cos phi, cos delta, cos omega. ठीक है. हाँ, you can either follow 4.16 formulas. just 1 minute. You can either follow 4.16 formulas or these formulas 4.17 formulas. Okay, better you should go through 4.17 formulas. Okay, better you should go through 4.17 formulas because we have two frequencies. We have 2 times given omega 1 and omega 2. So you should go through this one. So please make a correction here. Theta means your phi. You have phi is 11.0183 and you have delta is around minus 2.416 degree you have got. And omega 1 plus omega 2 by 2. You first write omega 1 is 12 minus 11 into 15 and omega 2 is 12 minus 12 into 15, which is omega 1 is 15 degree, omega 2 is 0 degree. So 15 plus 0 means 7.5. Then delta is with you, sin phi is with you, and n is 75. And please see one solar constant you need ISC. ISC solar constant value is 1.367. I have last class I have told you solar constant value is 1.367. Okay, so please first calculate I0 value using this formula. Please take a screenshot of these formulas first. Please take a screenshot or write down these formulas. Okay. It is the monthly average of the global extraterrestrial radiation. ये हमें निकालना है. प्लीज इसका एक बार स्क्रीनशॉट ले लो. हो गया होगा पर आप स्क्रीनशॉट या रिटर्न जस्ट 1 मिनट टाइम दे रहा हूँ. आप इसका स्क्रीनशॉट लिख लो. मैं फिर बाद में बाकी चीज बता रहा हूँ कैसे इस प्रॉब्लम को प्रोसीड करना है. ओके सो ये हो गया होगा. ये लिख लिए होंगे. तो आपको बता रहा हूँ मैंने 4.7 प्रॉब्लम में जा रहा हूँ. जस्ट 1 मिनट. हाँ सॉरी ये 4.6 का प्रॉब्लम है 7 नहीं. तो इसमें हमारे पास डेल्टा का वैल्यू है. आपका वैल्यू यूज कीजिए प्लीज. ओमेगा इसका वैल्यू आपके पास है उसको रेडियन में ले लीजिए. देन ओमेगा इज मैंने बताया 11 और 12 के बीच में. तो एक आएगा ओमेगा 1 इज 15, ओमेगा 2 इज 0. सो इट विल बी 7.5. प्लीज कैलकुलेट I0 बार फर्स्ट. I0 बार या IG दोनों सेम है. प्लीज कैलकुलेट. Setopatma Asna, have you got it? How to calculate? Please use the formula and calculate I0 bar. ये थोड़ा टाइम लगेगा. नो नेट वरी. ये थोड़ा टाइम लगेगा. फिर प्लीज इसको कैलकुलेट करो. एंड इसका भी यूनिट होगा किलो जूल पर मीटर स्क्वायर. Who is Kitty 3275 RT? It's your first class perhaps. What's your name?
Ipsha.
Can you please again tell me?
Ipsha.
Okay. Are you following?
Yeah.
Okay. थोड़ा कैलकुलेशन अच्छे से देख के करना. ये गलत हो सकता है. ये अगर गलत हो गया तो पूरा आंसर ही गलत आएगा. Have you calculated I0 bar? Anyone? What is the value?
3244.80663.
324.
Yes.
Can you please again calculate? मुझे थोड़ा मैंने calculate किया था मेरा 4564 आया. Please check it. Again please check it. सारे डेटा आपके पास है. Please check it. आप यही फॉर्मूला यूज किए हो 1 + 0.033 कोसाइन 360n by 365 cos phi cos delta. So please again calculate. एक बार कहीं आपका गलती हुआ होगा. Please check it, Shwetabadma Vansa.
Yes, sir.
Have you calculated again, Satyapadma and Asna? Have you calculated I0 value?
Yes, so I'm getting around 4,000.
4,000.
Yeah.
कहीं तो आप गलती किए हो. Asna, have you got what is the I0 value? Have you calculated?
Yes, sir. 4,500 something.
Something means कितना आ रहा है?
सर एक्चुअली गलत हो जा रहा है कुछ कहीं कैलकुलेशन में बार बार 4,000 ही आ रहा है मेरा भी बट आई विल डू सर गिव मी वन मोर चांस
ठीक है ठीक है, एक 2 मिनट और कैलकुलेट कर लो, अदरवाइज हम 4,000 प्लीज देख लो एक बार. ये थोड़ा डिफिकल्ट कैलकुलेशन है, आप लोग को इतना बड़ा बड़ा कैलकुलेशन करने का मतलब प्रैक्टिस नहीं है ना. अब थोड़ा पहले ये ब्रैकेट में जो टर्म है कोसाइन 11.0183 आपका -2.417 आया था, कोसाइन 7.5 उसका वैल्यू कैलकुलेट करो, फिर जो पैरेंथेसिस में उसका वैल्यू कैलकुलेट करो, फिर 3600 मल्टीप्लाई करो, आपका लगभग देखना एक बार, उसका आंसर अगर वही आए तो हम उसी को लेके प्रोसीड करेंगे. जस्ट ट्राई फॉर 1-2 मिनट.
सर ओमेगा 2 माइनस ओमेगा 1 की वैल्यू 15 लेंगे
अच्छा, इसीलिए आपका गलत आ रहा है. मैं 4.17 का मतलब 4.17 फॉर्मूला यूज करने को बोल रहा हूँ, ठीक है. गट माई पॉइंट, इसीलिए आपका गलत आ रहा था. आप ओमेगा 2 माइनस ओमेगा 1 कर रहे थे क्या?
4.16 वाला.
अच्छा नहीं, 4.17 वाला यूज करो, ठीक है. गट माई पॉइंट, वो भी आएगा. एक्चुअली दिस इज द मोर अप्रोप्रिएट वन. जब आपका 2 टाइम ड्यूरेशन दिया होगा तो प्लीज यूज 4.17. ओके, प्लीज यूज 4.17. एंड आपको पता है 5 डेल्टा ओमेगा 1 प्लस ओमेगा 2/2 इज 7.5. साइन डेटा डेल्टा साइन थीटा, साइन 5 थीटा नहीं 5 है. Have you got any value? I0 value?
Four thousand 562.342.
ओके, हाँ ठीक है. सो एक बार आपका I0 आ जाने के बाद when you will get I0, then what you will do, I0 बार आपका आ गया. देखो H0 बार आपके पास है. So please calculate now A and B using 4.25 formula. You have already calculated omega s is around 89 point something या 1.56 डिग्री. सो जहां पे आपको साइन ब्रैकेट में ओमेगा एस है ना, आप वहां पे डिग्री लेना, नॉट रेडियन है. जहां पे 60 से माइनस हो रहा है इसलिए आप रेडियन डिग्री लेना. तो ए एंड बी का वैल्यू कैलकुलेट करो. इसके बाद अब ए एंड बी का होने के बाद प्लीज यूज द फॉर्मूला 4.24 एंड कैलकुलेट एफ सी. ओके.
Sir, 5,369.
I0
Yes.
थोड़ा कैलकुलेशन 5300. ठीक है, जो भी वैल्यू है, जो भी वैल्यू है उसको कंसिडर करो. ठीक है, थोड़ा इधर उधर है, जो भी वैल्यू है उसको कंसिडर करो. फिर क्या करना है, ओमेगा एस 89 पॉइंट समथिंग आया था प्रीवियस क्लास में. तो आप ओमेगा एस का 89 पॉइंट समथिंग जो वैल्यू आया था उसको यूज करके ए एंड बी का वैल्यू कैलकुलेट करो. जब ए एंड बी हो जाएगा, देखो फिर यू हैव टू कैलकुलेट एफ सी. तो जब एफ सी कैलकुलेट कर रहे हो, खाली ओमेगा एस जहां पे है ना, आप वहां पे रेडियन का वैल्यू यूज करना. जहां पे साइन या कोसाइन है वहां पे आप डिग्री का वैल्यू यूज करना, फिर एफ सी कैलकुलेट करना. ठीक है, प्लीज कैलकुलेट ए एंड बी फर्स्ट.
So A is 0.65761
Okay.
and B is
0.42. 0.42. Yeah, how much?
432.
B is how much? Point.
0.432.
0.425.
ओके ठीक है. B का A and B का वैल्यू जब आ गया, then please calculate FC. Have you calculated FC?
No.
Okay, please calculate C. Omega S is around 1.56 radian. You have calculated last class.
Yes, sir.
हाँ, तो use that omega S value and जहाँ पे आपको डिग्री में कैलकुलेट कर साइन, जहाँ पे साइन कोसाइन है आप डिग्री में ले लो. 89.6 या कुछ आया था, देख लेना एक बार. एंड साइन या कोसाइन के साथ जब है तो डिग्री में लेना एंड ओमेगा एस जहाँ खाली है उसको रेडियन में लेना. प्लीज कैलकुलेट एफ सी. जस्ट 1 minute है.
Sir, FC is equals to 0.98.
ओके सो आपको यही बताना चाहता था मैंने. आप एफसी का वैल्यू ना तो बिना कैलकुलेट करे भी अगर एग्जाम में टाइम नहीं हुआ, आप एफसी का वैल्यू मैं बता रहा था कि 1 के बराबर होगा. 0.98 0.99 ऐसा वैल्यू होगा हमेशा फॉर एनी वैल्यू ऑफ एंड बी. ठीक है, तो आप इसीलिए एफसी का वैल्यू को हमेशा 0.97 से 1 के बीच में रखना अगर कैलकुलेशन करने का टाइम नहीं मिला तो. ठीक है, सो व्हेन यू विल गेट एफसी, जस्ट आई एम गोइंग टू द टॉपिक. Okay, so when you have calculated FC, you have all the values. आपको ओमेगा पता है, ओमेगा इज योर 7.5. ओमेगा एस इज डिफरेंट, ओमेगा इज डिफरेंट. ए पता है, बी पता है. H0 bar previously you have calculated, I0 bar you have calculated. You have to calculate only IG bar. So please calculate monthly average, hourly global radiation. That will be. What others are doing? Anybody following? Satvik Das, are you following? Amit Mahapatra? Siddhant Sarup Malik, have you done anything?
Yes, sir. I'm following.
What is A value? Can you tell me?
I'm calculating, sir.
Okay. Then I0 value?
What, sir?
I0 bar value.
So can you come again, please?
I0 bar value. Have you calculated I0 bar value? A and B. I0 bar value, how much you got? Okay. Siddhant Swarup Malik, are you there? Nobody is listening except 1, 2. ठीक है, I know it's on means आप लोग को दिक्कत है, but others are also doing ना?
Yes, sir, doing.
Sir, I0 bar value is 4562.342.
Okay. What is the unit?
Unit is
आप लोग का इंटरनल ग्रुप है, उसमें पूछ रहे हो ना? Am I right?
no, sir. I have calculated.
यूनिट को कैलकुलेट क्या कर रहे हो? मैंने तो यूनिट बोल के गया, यूनिट को कैलकुलेट क्या कर रहे हो?
Unit I haven't heard. That's why I
No,
but I followed the process, that formula.
Kilojoules per
Just
meter square by meter square.
Kilojoule by per meter square. No need to worry. Just I am joking यार. No, why you people are so serious? ठीक है, मैं जानता हूँ आप लोग मतलब मंडे टू फ्राइडे काम करके भी क्लास आ रहे हो. दैट इज ऑल्सो मतलब बिग थिंग, बिकॉज आप इतना मतलब रोज रोज इतना 8 घंटा करके इंटर्नशिप करके भी आप क्लास कर रहे हो एट ए टाइम. यू पीपल आर मैनेजिंग बोथ द थिंग. दैट इज ऑल्सो ग्रेट थिंग. ओके, मे बी नॉट फॉर अदर बट फॉर मी इट्स अ ग्रेट थिंग. ओके, सो आई एम जस्ट जोकिंग. व्हाई पीपल आर सो सीरियस? ठीक है सत्विक, हैव यू अंडरस्टैंड? नो नीड टू वरी. ओके, थोड़ा फॉलो करो. ओके, थोड़ा फॉलो करो. आई नो इट्स अदर ब्रांच सब्जेक्ट, आपको इतना इंटरेस्ट नहीं
Actually,
आएगा.
I was having my lunch, so that's why I couldn't hear.
नो प्रॉब्लम. देखो कि आपको ये अदर ब्रांच का सब्जेक्ट है, इतना ज्यादा इंटरेस्ट नहीं आएगा. अगेन यू पीपल आर वर्किंग फ्रॉम मंडे टू फ्राइडे एंड अगेन सैटरडे 10 to 6 8-hour class, and Sunday those who are with you working in the office, they are just going for outing, they are chilling, and you people are doing class. I know it's little bit नहीं, बहुत ज्यादा हेक्टिक है. इवन हम मतलब इवन मैं होता तो भी मैं मतलब दिमाग खराब हो जाता, बिकॉज मंडे टू फ्राइडे 8 घंटा काम करना, अगेन 8 घंटा क्लास करना, इट्स लिटिल बिट हेक्टिक. ठीक है, तो जस्ट आई एम जोकिंग, नो नीड टू वरी. जब मैं किसी को आंसर पूछ रहा हूँ, अब प्लीज थोड़ा सेंसिटिव मतलब सीरियस रहो. ठीक है, मैं जो बोल रहा हूँ एटलीस्ट प्रोसेस फॉलो कर दो. ठीक है, अगर नहीं हो रहा है मूड, अच्छा डू यू पीपल वांट मैं 1 घंटे के बाद 5 मिनट ब्रेक दूं क्या? 5-10 मिनट का ब्रेक चाहिए, या मैं जल्दी छोड़ दूं, वो 2:45 ऐसा छोड़ दूं, चलेगा? या अभी 5 मिनट का ब्रेक चाहिए?
जल्दी छोड़ दीजिए.
तो जल्दी छोड़ दीजिए.
अच्छा ठीक है. प्लीज कैलकुलेट IG बाय. इसके बाद भी आपका क्लास है एक और?
यस सर. 4 to
Which
6.
class is this? Which class?
Operational research OR.
Okay. Please calculate IG bar by HG bar values. मैं मेरे बारे में बता रहा हूँ. आप तो इंटर्नशिप करके क्लास करते थे, मैं तो 8th सेमेस्टर में खुद ही ऐसे क्लास नहीं करता था. मैं जब पढ़ रहा था बेटे, मतलब मैं तो खुद ही ऐसे क्लास नहीं करता था. एंड यू पीपल आर एटलीस्ट डूइंग क्लास, दैट्स अ प्लेजर फॉर मी. एटलीस्ट आप लोग तो सीरियस हो, इसीलिए क्लास कर रहे हो. एंड बहुत सारे तो एटलीस्ट 12 लोग प्रेजेंट है, तो 3-4 लोग तो रेस्पॉन्ड कर रहे हो. आई एम जस्ट फॉरवर्डिंग द न्यूमेरिकल्स आंसर. मैं कल भूल गया, मैं थोड़ा स्क्रीन शेयर बंद करके मैं न्यूमेरिकल जो था उसका सॉल्यूशन भेज रहा हूँ आपको. मैं कल भूल गया, जस्ट 1 मिनट. ऑल ऑफ यू प्लीज चेक. मैंने आपका जो ऑनलाइन एक ग्रुप था, वो ग्रुप में मैंने भेजा हूँ आपको न्यूमेरिकल्स जो प्रीवियस क्लास में सॉल्व कर रहे थे ना, उसका सॉल्यूशन सब भेजा हूँ. ठीक है, एक 46 पेजेस का है उसका. डोंट वरी, 46 पेजेस मतलब बहुत ऐसे गैप दे दे के लिखा है, इसलिए 46 पेजेस का है. ठीक है, उसका सॉल्यूशन जस्ट भेजा, एक बार देख लेना.
Sir, the answer is 3193.370.
आईजी बार, हाँ आईजी बार का इतना ही आया है. आईजी बार का इतना ही आया है वैल्यू. सो 31312.22 किलो जूल पर मीटर स्क्वायर. ठीक है, तो इसका ये है मंथली एवरेज आवरली ग्लोबल रेडिएशन. मतलब पूरा मार्च मंथ का 11 to 12 o'clock, what is the global radiation from Coimbatore in Coimbatore location situated in this much latitude? This is the answer. Okay, so anybody answer? Asna, have you got it? आपका कितना है आसना?
Sir, 3335.15.
Okay, so this is your IG bar value. नेक्स्ट हम चलते हैं मंथली एवरेज आवरली डिफ्यूज रेडिएशन. ठीक है, जो हम पढ़े थे प्रीवियसली मंथली एवरेज, जो हम गर्ग एंड गर्ग फार्मूला एंड हम जो पढ़े थे गोपीनाथन सोलर फार्मूला, वो था ओनली मंथली एवरेज डिफ्यूज रेडिएशन. इट इज मंथली एवरेज आवरली डिफ्यूज रेडिएशन. ठीक है, सेम फॉर्मूला जो प्रीवियस में फॉर्मूला था, IG बार बाई HG बार इक्वल टू I नॉट बाई H नॉट इंटू A प्लस B cos ओमेगा डिवाइडेड बाई FC. यहाँ बस FC नहीं है. ठीक है, A प्लस B cos ओमेगा है. एंड A एंड B का आपको क्या करना पड़ेगा, HD बार बाई H0 HG बार आपको चेक करना पड़ेगा. डिफ्यूज रेडिएशन का फॉर्मूला हम ऑलरेडी कैलकुलेट किए थे गोपीनाथन फॉर्मूला से या गर्ग एंड गर्ग फार्मूला से. हम ऑलरेडी HD बार कैलकुलेट किए हैं. तो आपको क्या करना पड़ेगा, इवन HG बार वी हैव कैलकुलेटेड प्रीवियसली इन द फर्स्ट क्वेश्चन. वी हैव कैलकुलेटेड HG बार and HD bar we have calculated from Gopinathan solar formula in today's class. So you have to check the ratio. If the ratio is falling between 0.1 and 0.7, you have to use the formula 4.28 to calculate A, 0.4922, then 0.27 by HD by HG bar. Or else if your HD by HG bar is different and it is greater than 0.7 and less than 0.9, so it will be within this. You have to use this formula 4.29, and for B you have to use this formula 2 into 1 minus A sin omega s minus omega s cos omega s. No need to worry, this formulas will be, जो बहुत बड़ा फॉर्मूला दिख रहा है ना, वो हम एग्जाम में दे देंगे. जैसे कि छोटा फॉर्मूलाज है गोपीनाथन सोलर का, जैसे छोटा सा फॉर्मूला है उसको, सॉरी गर्ग एंड गर्ग का एक बहुत छोटा सा फॉर्मूला है, उसको नहीं देंगे. ये जैसे कि आप देख रहे हो कि बी का एक बहुत बड़ा सा फॉर्मूला है. ठीक है, ये फॉर्मूला हम एग्जाम में प्रोवाइड कर देंगे विथ क्वेश्चन. ठीक है, सो बी इज दिस मच 2 into 1 minus. सो इसीलिए आपको बोल रहा हूँ जस्ट एग्जाम मतलब फॉर्मूला यूज करना सीख जाओ. When you have formula, you will definitely get the answer. B equal to 2 into 1 minus A sin omega s minus omega s cos omega s divided by omega s minus 0.5 sin 2 omega s. Please give the heading monthly average hourly diffuse radiation and please write down these 3 equations. ठीक है, please write these 4 equations. ठीक है, please write down these 4 equations.
Excuse me, sir.
हाँ.
Sir, in which group have you sent
ऑनलाइन क्लास 24 का ग्रुप है ना, आप नहीं हो उसमें?
No, sir.
ऑनलाइन, एक मिनट, ऑनलाइन
I am also not there.
ओके, जस्ट 1 मिनट, मैं चेक कर रहा हूँ. अरे अलग ग्रुप में चला गया, जस्ट 1 मिनट. Can you people now check? एक आरी ऑनलाइन क्लास 21 एक ग्रुप है.
Yes, sir.
You people are there in the group?
Yes, sir.
Now I have sent. मैंने कल एक्चुअली आपका जो ऑफलाइन क्लास है उसमें भेज दिया था. सो एक बार चेक कर लेना, वो आंसर सारे न्यूमेरिकल जो प्रीवियस सैटरडे संडे को कर रहे थे उसका सारे सोल्यूशन है, ठीक है. एंड इसका भी ये भी इस नेक्स्ट वीक इसका भी कुछ सॉल्व करेंगे प्रॉब्लम, तो इसका भी सॉल्यूशन मैं दे दूंगा, ठीक है. एंड प्लीज राइट डाउन दिस 4 इक्वेशन, ID बार HD बार वैल्यूज, प्लीज राइट डाउन दिस 4 इक्वेशंस. इसका पूरा प्रॉब्लम नहीं करेंगे, जस्ट आपको ए एंड मतलब ए एंड देखते हैं, जब जितना तक जाता है वो करेंगे, सॉल्व करेंगे. सेम प्रॉब्लम वी वांट टू फॉलो. सो प्रीवियसली प्लीज चेक व्हाट इज द HD बार वैल्यू यू गॉट respectively. Please write what is the HD bar value you got from your equations, HD bar value. Okay, please write that one. And your first we have to check HG bar. You have HG bar also. Please calculate HD bar divided by HG bar. Again and again I am saying, please calculate HD bar divided by HG bar. ठीक है, एक बार कैलकुलेट कर लेना है. व्हाट इज द वैल्यू, प्लीज टेल मी. दोनों वैल्यू आपके पास है, HD बार बाय HG बार आप कैलकुलेट कर लो. ये हम 4.7 सॉल्व कर रहे हैं मंथली एवरेज. हाँ,
We will use which formula?
Gopinathan and Solar formula. This is the most appropriate formula in India.
Sir, 0.25.
Okay, so when it is 0.25, see, it is within the range of 0.1 to 0.7. Okay, so please use HD bar by HG bar ratio and calculate A. Calculate A, and A आ जाने के बाद, so you have to use the first one 4.28. A आ जाने के बाद just B भी calculate कर दो. इसके बाद हम next class cover करेंगे. A and B का वैल्यू कैलकुलेट कर दो जस्ट एक बार. Have you calculated A and B? A तो हो गया होगा.
A is 1.57 total.
A
Yes.
या B? Okay.
A.
So B एक बार कैलकुलेट कर लेना. B एक बार कैलकुलेट कर लेना. ये थोड़ा मतलब थोड़ा कैलकुलेशन थोड़ा टाइम लगेगा B का. हम B का कैलकुलेशन नेक्स्ट क्लास देखते हैं. ठीक है. B और इसका ये प्रॉब्लम को हम नेक्स्ट क्लास कंटिन्यू करेंगे. Just 1 minute. I have to take an attendance. Just 1 minute. Amit Mahapatra, Angana.gm, Angana Ghosh Majumdar, Anisha Swain 45. Anisha Swain 45. Yes, your name is Anisha Swain, yeah? ठीक है. असना एसिका भरती अर्पण किटी 3275 RT. Kitty 3275 RT. Can you tell me what is your full name?
Ipsha Raut.
Okay. Then Satvik Das 872. Satvik Das, Siddhant Swarup, Vaibhav Singh, Supriti. Supriti, are you following?
Yes, sir. Yes, sir.
ओके आपको मतलब आपका सारा आंसर आया? मैं देखा नहीं था, आप लोग भी प्रेजेंट
sir,
हो,
अभी-
आपका आंसर है? ठीक है
हाँ
ठीक
हाँ,
है।
I have got, I have calculated, yes.
Okay, Susri dot Sriya. What is your name? Susri dot Sriya. What is your name? Can you please tell me? सुश्री किसी को अगर पता है तो नाम बोल दो। व्हाट्स हिज नेम? व्हाट्स हर नेम?
सुश्री श्रेया मिश्रा.
ओके, सुश्री श्रेया मिश्रा. then शुभम पटनायक, श्वेतोपद्मा दास. ठीक है, शुभम पटनायक, श्वेतोपद्मा दास. ठीक है, you can leave now, no problem. Thank you. All of you can leave now, eh?